So at this point, we've gone through an overview of parallel streams. I've given you an example using the search stream gang parallel streams implementation to kind of go back and make a few minuscule little tweaks to the earlier sequential search streams example. And now what we're going to do is we're going to take a deeper dive into the way that parallel streams work internally. And so I'll start out by giving you kind of an overview. We'll talk about the way that the streams framework is designed and implemented. And you can learn more about this by taking a look at the article that's linked at the bottom of this page. I think I have to update the link here, but I'll do that on the PDF version of the slides that I put out here shortly. For some reason, IBM rearranged their website, and I have to keep making these changes. Half the battle, as always, is knowing what you can change and what you can't. Just like in real life, you need to accept the things you can't change, just learn to live with the constraints of the framework, and then get smart enough to know what you can change and courageous enough to know what you can change. So as we've seen, converting a sequential stream to a parallel stream is quite simple. Syntactically, you just change stream to parallel stream. Nothing too hard there. However, it's useful to know more things you can do to customize the behavior of the streams. And we'll see later that that makes a big difference in terms of performance, especially when you start getting into the parallel streams world, where there's major differences in performance, even though the semantics may turn out to be the same. To kind of structure this discussion, let's briefly recap the three phases of a parallel stream. There's the split phase, where we use spliterators, either ones we develop or ones that come out of the box, to partition a data source up into chunks that are then processed in parallel. The processing in parallel takes place in the next phase, which is the so-called apply phase. And these chunks are processed in the context of something called the common fork join pool. We've talked about the common fork join pool before. We'll talk more about it later, but in a nutshell, it's a common pool where all parallel stream processing takes place. And after the processing takes place in parallel, then we're going to go ahead and combine the results back together again by using the join capabilities that are built into the underlying fork join pool. Mercifully, the bulk of these details are hidden from you, but you'll need to know just sort of how you program this using the stream's functional programming abstractions. You can control the split phase, you can control the combine phase, and you just have to accept the way the apply phase works. The apply phase really is done for you, and you have little or no control over it, although you can do a few little tweaks like change the number of threads that are used in the pool, and we'll talk more about that later as well. So that's just a real quick overview of the concept of parallel streams internals. Now what we're going to do is we're going to do deeper dives into each of the things that can be changed, and we'll see how those changes and those behaviors manifest themselves in the form of something that you can actually see and control in your code.